our mathematics assignment, which is based on currency exchange from Malaysian ringgit to United States dollar. Currency exchange can be presented as a function because each amount in NYR is converted into exactly one corresponding amount in USD. The exchange rate used in this example is 1 USD equal to 3.98 MYR. Therefore, the function is fx equal to x over 3.98, where x represents the amount in NYR and fx represents the amount in USD. For example, f2 equal to 2 over 3.98 equal to 0.30 USD. f3 equal to 3 over 3.98 equal to 0.75 USD. And the last one, f4 equal to 4 over 3.98 equal to 1.10 USD. Next, the codomain or set S is 234, which is represent the volume in NYR. The codomain set or set Y is 0.50, 0.75 and 1.10, which is represent the value in USD. In the mapping diagram, to map to 0.50, 3 map to 0.75, 4 map to 1.01. They show that every element in the domain is connected to exactly one element in the codomain. The mapping diagram we call as 1-to-1.
Everyone, today I will explain my part about composition function and inverse function using a real-life example of currency exchange between Malaysian ringgit MYR and United States dollar USD. First, let us look at the composition function denoted as G composed with F. A composition function combines two related processes into one complete process. In this example, the first function f of x represents depositing Malaysian ringgit into the exchange system. The second function g of x represents converting the ringgit into US dollars. Therefore, the composition function is written as g composed with f of x equals to g of f of x. The process can be understood as first the customer deposits MYR, then the exchange system converts it into USD. Given the exchange rate is 1 USD equals to 3.98 MYR, the conversion function is g of x equals to x divided by 3.98. For example, if a tourist exchanges 4 MYR, the amount received in USD is 4 divided by 3.98 equals to 1.01 USD. In conclusion, the composition function shows the process of converting MYR into USD, while the inverse function reverses the process and converts USD back into MYR. These two functions are related because they undo each other, which means f of f inverse of x equals to x and f inverse of x equal to x. Thank you. That's all for my presentation on USD. Next, I will explain the inverse function. An inverse function represents the reverse process of the original function. In this case, it converts USD back into MYR using the same exchange rate. The original function is f of x equals to x divided by 3.98. To find the inverse, we replace f of x with y. So swap x and y and solve for y. The inverse function becomes f inverse of x equals to 3.98x. For example, if a tourist has 1.01 USD and wants to convert it back to MYR, so it's 1.01 times 3.98, so we get 4.02 MYR.
I will be presenting the graph theory module from our discrete mathematics assignment. First, let's look at the vertices. In our graph, we have four entities representing as a set V, equal to A, B, C, and D. Next, we have the edges, which represent the transaction pass and cash delivery agreement between these entities. As you can see in our diagram, this is an undirected graph, meaning the connection works as two-way channel. For example, E1 and E4 connect to the tourism and the local exchanger for exchanging currency. For example 2, E2 and E3 connect to the local exchanger to the central bank for cash deposit and USD supply. Finally, H5 connect to the central bank and the international exchange counter for reserve adjustment. Let's look at the calculating degree of vertex. The degree of vertex simply means the total of the edges connected to it. Based on our graph structure, the degree A is 2, the degree B is 4, the degree C is 3, and the degree D is 1.
Good day everyone, I will explain three parts of our project, which are the adjacency matrix, the tree of module, and the conclusion. First, the adjacency matrix. In our currency exchange system, we represent the relationships between four verticals: tourist, local, exchanger, main bank, hub, and international exchange counter. The adjacency matrix shows how these verticals are connected using numbers. A value of 2 means there are multiple connections of transactions between two entities. From our matrix, we can see that the local exchanger has the highest connection, which shows it plays an important role in the network as the main hub of transactions. Next is the tree module. A tree is a connected graph without any cycles. In our project, we use it to represent the step-by-step currency exchange process. The root node is currency exchange. Then it branches into two main process, which are the converting ringgit MYR to USD and USD to MYR. The final result, which are the converted amounts, are the leaf nodes. This tree helps simplify the decision-making process in currency conversion. Finally, the conclusion. This project shows how the discrete mathematics apply in real life. The function explains currency conventions. The graph theory shows relationships between entities, and the tree structure simplifies decision process. Overall, it helps us understand how mathematical models can represent real financial system in an organized way. Thank you.